Lewis structures or Lewis dot structures are a common and convenient way to represent structural formulas for covalently bound molecules. So if we look at a molecular formula, in this example for a propanol, C3H8O, one of the challenges is that with this relatively simple chemical formula, there are several ways that the atoms can be arranged. And each of these are different chemicals that will have different properties. So in the upper left here, the oxygen is on one of the terminal carbon atoms of that 3-carbon chain, and this would be N-propanol. In the upper right, the oxygen is attached to the central carbon, and this would be isopropanol or 2-propanol. This is rubbing alcohol. And in the bottom, instead, we put the oxygen in between two different carbon atoms, and this would be a methyl ethyl ether. Different chemicals, different properties, different reactivity. The Lewis dot structure primary tool or primary goal here is that it shows connectivity between atoms. It shows which atoms are attached to which other atoms, and that can be very useful in understanding chemical reactivity. We can also use it as a starting point to start talking about molecular shape, molecular polarity, and other properties that are useful to predict and understand about these molecules. So here I have some Lewis dot structures for simpler molecules, and I want to point out some elements of these structures. So first of all, each of the atoms in the molecule are represented by letters, and they're each separate. You don't do an H2, for example. Each atom is represented separately. The other thing I want to point out is that we have two types of electrons, or two ways in which electrons are represented. These pairs of dots on the side are non-bonding electrons. They're also called lone pairs. These electrons are localized on that oxygen atom, and they're not really shared with anything else. These lines are bonding electrons. Each line represents 2 electrons. Okay. In this example, between the oxygen and the hydrogen atom, there is a single bond, 2 electrons. Now, some books will represent this as dots like that. This isn't very useful going forwards. I would suggest you not use that notation, that you be sure that you're representing bonded electrons as lines, so it's very clear which ones are non-bonding, represented as pairs of dots, or bonding, represented as lines. So each dot is 1 electron, each line represents 2. Sometimes we have double bonds, or even triple bonds. So in a single bond, there's 2 electrons in that covalent bond that are shared between the oxygen and the hydrogen. In a double bond, there are 4 electrons that are shared between, in this case, a carbon and an oxygen atom. Okay, and in the hydrogen cyanide example in the top left, there's a triple bond, or 6 total electrons that are shared between that carbon and that nitrogen atom. We'll talk and I'll have some examples in how you can draw these structures for simple molecules with a single central atom, but the process is going to be pretty straightforward. We need to know how many total electrons to use in this structure. The electrons in a Lewis dot structure represent the valence electrons of each atom, the electrons on the outer surface that can interact with one another. So we're going to total the valence electrons provided by each atom in the molecule, and then adjust it if it has an overall charge, if it's an ion. Then we need to get the relative structural arrangement. We're going to put the least electronegative atom in the center and put the others around the outside. And then we start distributing electrons. And there's a set of rules for how we do this to help us get to the right structures as easily as possible. And the next couple videos will walk you through that.